All right, just before I start, I need to vent for a minute. Have anyone ever been to Norway? Well, I haven't, but that's where my employer Whitson's based. And for emails, for some reason, they don't use Outlook. They use this like Norwegian alternative called Mosric. And yeah, I mean, when I get to work in the morning, the first thing I have to do is go find this shared folder we all use. It's got kind of a spreadsheet of each day's emails, and then I go find the newest one, which is kind of up to date to so far. And just to give you an idea, you open one of these spreadsheets and it has everybody's email for the whole company. And so here, I guess Tom is telling Mo, hey, there's something fish in the fridge or something. So anyway, I have to then import that spreadsheet into Mosric to see everybody's emails and then filter it down to mine. And then this is not like a live connection. So I have to, every half hour, I kind of go and find the new spreadsheet and copy paste it locally and import it. So I figured out a way to filter just down to my emails in Mosric. For calendar invitations, it's the same thing, but they're in like a different shared folder. So I have to do that. I do that every hour or so. And then, for sending a new email or replying, it's a whole nother process for email. So, this is kind of new for me. I mean, just like you, I've been using Outlook for most of my career. I got to say, this whole Mosric thing is probably one of the most time-consuming things I've done at work that I kind of, took Outlook for granted. The problem is this is my life now, right? I've become used to it, and I've kind of just accepted it. Yeah. Okay. I'm going to confess. I'm just kidding. Okay. I use Outlook but imagine if this was our reality for doing emails and calendars, right? We kind of just take it for granted how easy and automated it really is. But it would be just an insane amount of wasted time and effort for everyone at your company to do it the way I just described, right? But here's a crazy fact. There are a ton of engineering tasks that people do every single day that are just as crazy and just as inefficient and painful. Okay, so what if we could take some of these, regular engineering tasks and automate them, just as easy as we do emails, right? So that's what we're going to talk about today is automating results that engineers use every day. My name's Graham Helfrich. Hopefully we've talked or met before, but I started at Paquette almost 18 years ago and I had a lot of fun doing rate transient analysis and production optimization. So now I'm at Whitson, which is based in Norway, and they use Outlook. So today's example is about Devon, but it's also been performed at Ovintiv and dozens of other operators. So we're going to look at Devon's case today, okay? So at Devon, they wanted to look for the low-hanging fruit, which in their case was daily bottom hole flowing pressures for every well. And I'm talking 5,000 wells. So we're going to look at what had to happen for this to come together, and then what are some hurdles that Devon and maybe other operators have had to overcome to accomplish this. So first, what the heck is a bottom hole pressure? So for every well, we've got a sensor or a gauge at the top of the well, and every day it's recording what that flowing pressure is. And so over the well's life, we build up a record of what its surface flowing pressures were. Here we have 3 years. But what engineers really want is the bottom hole flowing pressure. And that can be hundreds or thousands of PSA higher than what the pressure is that we're measuring up at the surface. Now, one thing you could do is you could put a sensor or a gauge down in the bottom of the well here, right? This is thousands of feet down. And you could do that, but guess how many wells in North America, unconventional wells, actually have a sensor or a gauge downhole monitoring pressure? Only about 5%. And the reason for that is it can be quite expensive, depending on who you talk to, up to $50,000 per well. So instead, the accepted way to get the bottom hole flowing pressure is to take the measurement that we have at the surface and use math and physics and some proved methods and calculate or infer what that bottom hole flowing pressure is. The problem is there's no easy way to do that automatically, and that's what we're talking about today. So why do we even care about bottom hole flowing pressure? So let's pretend that you and I, we go in and we invest in a well together. This is our well. It started at 1,000 barrels a day, and now we're down to 200 barrels a day. Okay, cool. Now our competitor, they have well B. And their well also started at 1,000 barrels a day, and now it's down to 200 barrels a day. So the history and the rates of these wells, they're identical, right? If you did a decline or a forecast on these two wells, they'd have the same EUR, the same economics. So, what about the flowing pressure? So our competitor has been operating at a very low bottom hole flowing pressure. Well, our well has been operating at a very high bottom hole flowing pressure. Okay, what does that mean? So let's imagine that we're in a car race. So we're in the green car and we're racing against the red car, and the cars are right beside each other. They're going the exact same speed. No one's winning the race. And we look over, and the red car, the driver has his foot floored. The throttle is all the way down to the floor, 100% throttle, and he's going the same speed that we are. We look down at our foot, and we're only half throttle, right? Our foot is only half the way down on the pedal, and that means that we have an opportunity. So which of these two cars is going to win the race? We are, because we're going to floor it, and we're going to go faster than them. Okay? So with our flowing pressure, it's the same thing, that our competitor, the red well, their flowing pressure is low, and that's the same thing as saying that our foot is floored. They're producing at the highest rate that they can by having a low bottom hole flowing pressure. Well, our well has a high flowing pressure, and that's the same thing that as if we have our pedal only halfway pushed down on the throttle. And if we wanted to go faster, if we wanted to increase our rate, all we have to do is floor it, and that we have that option for our well. So our well's better. Okay, so if basically bottom hole flowing pressure has a huge impact in what our rate's going to be. Okay, so since we know that the bottom hole flowing pressure is important, what else do people do with it, right? This is basically our surface pressure, our bottom hole flowing pressure that we're calculating. Well, from the bottom hole flowing pressure, we will do reservoir simulation, numerical modeling, things like that. We'll also do rate transient analysis, pressure transient analysis. We need the bottom hole flowing pressure. There's this technique called flowing material balance. We need the bottom hole flowing pressure. That is a technique to estimate the fluids in the reservoir, how much is down there. Wellbore optimization. This is what production engineers will do. They'll help design and plan and optimize the well through changes in the wellbore, changes in the surface, what's going on, artificial lift, and we need the bottom hole flowing pressure for that. And then production diagnostics. Is my well's productivity getting better? Is it getting worse? Is there interference with a neighbor well? We need bottom hole flowing pressure for all these things. And then also things like AI or machine learning will use bottom hole flowing pressure as an input. So the fact is, if all these engineering methods, which are used pretty much every day, require bottom hole flowing pressure, wouldn't it make sense to automate that bottom hole flowing pressure, right? All the efficiencies of automating this input are going to compound themselves and make all of these engineering steps more efficient as well. And that's why Devon and other operators pick bottom hole flowing pressure as that low-hanging fruit to automate. All right, so let's look at kind of the process that Devon did and some hurdles that they overcame. So the inputs that they need are the well's history for the daily volumes and the daily flowing pressures at the surface, right? We also need our wellbore description, right? How deep is our well? How big is the tubing? And that's where Peloton WellView came in. It holds a lot of these details about their wellbore. There's alternatives to WellView, but that's what Devon was using. And then we need some way to converge these two data sources into one place, and that's where an API connection will be used often, or in Devon case, Snowflake. I'll explain the differences between these and when they're advantageous. And then finally, we need some sort of engine, which is Whitson, to do the calculations, right? So we're taking production data, wellbore dimensions, using some way to connect and plumb or wire them into a calculator, which is Whitson, to do all these calculations and get the bottom hole flowing pressure result. So let's talk about API versus Snowflake, the ways we can get data in to Whitson. So, I'm not saying they're bad. I'm just saying that they both require work and they have different solutions. So an API connection, this is just a web protocol that is built to pass data from one application or source to another. It's important to mention that it does require some skills like Python or building scripts to make this happen. And there's a trigger for an API. It's called a call. And there's different ways to make a call, but an SDK is one of the ways to manipulate or automate these APIs. And that's what Oventive did, actually, to automate their bottom hole pressures. They didn't go the Snowflake route. They did API with SDK to automate that. So just basically this API option requires knowledge and skills, data science, engineering, IT to make it happen. But it is probably one of the most popular ways that we see operators doing. The other option is Snowflake. Okay, so Snowflake is a web-based service to host and hopefully consolidate data from multiple sources. Devon actually had about 30 different data sources that are feeding and connected into Snowflake. And then from there, they will just take parts, like I think they only take 4 parts of that table to get into Whitson to do the bottom hole flowing pressures. And so basically these consolidated data sets are picked using a table to send to any other third-party application that you want, whether it's Whitson or Pi or Spotfire or whatever. Now for Snowflake, there is an upfront investment to get it set up, like Devon did. But once that's done and your data is consolidated on Snowflake, then sending it to other sources like Whitson can be easier than an API connection potentially, right? So in short, if you have Snowflake, that's probably the easiest route because you've already invested in getting everything set up. If you don't have Snowflake, then the API connection is probably going to be your best route. The other thing to mention is if this seems all over your head and you don't really have the people in-house to perform this, there's a company called Conduit, and Conduit is they provide a service. They will perform this for you to wire everything up and get it automated for bottom hole pressures. All right. So what was the hardest part of this whole process for Devon? It has to do with the well bores. Okay. So we know that we're taking our surface pressures. We're trying to calculate the bottom hole flowing pressures, and all of the well bores, they have a different diameter. They have a different depth. That means there's going to be some different physics going on. We're talking about 5,000 wells. Not only that, the wells have baggage. They have history. And what I mean is, this well, initially it might have flown up the casing, right? A big flow path, easy to flow. And later they may have installed tubing within that well's life, right? That's a smaller flow path. It can be a little bit tougher to flow, or there's different reasons. And then they may have decided, okay, this well needs some help producing. We are going to install gas lift. And then later in the well's life, they may have switched to something like rod pump. And so the fact that the oil and gas down coming out of the reservoir, the path that it goes up to the surface will change through the well's history. And that is very important when it comes to calculating the correct bottom hole flowing pressure. So, WellView or other wellbore software will often have an archive of these details, but sometimes they don't. It just depends on how diligent people have been in entering them, and so this was one of the big hurdles, and it can be at operators, is making sure that they trust the history of these different flow paths, because we are going to be consuming and using that to come up with the correct bottom hole pressure. All right. So this was kind of the toughest part. And in cases where there's details missing about, what was the flow path, that's when you need to talk with production engineers and other people to just say, okay, what assumptions do we want to make that we think are safe and reasonable if we're missing data A, missing data B? And so that was just part of the work that has to go into getting this done sometimes. All right. So one of the key ingredients to making this all happen is our skills. Okay. Sometimes specialized skills. So in the case of Devon, Clark Thomas was their unicorn, I'll say. And not only is he skilled at, writing scripts and leveraging their Snowflake setup, but he also works extremely close with the asset teams. And that lets them apply logic and rules around the well bores. Okay. And, we love Clark. I think everyone at Devon does as well. So it's important to mention, Devon is not the only case. This has been done by dozens of operators. A different example is Oventive. And I'm not going to give you the full description here. In fact, Angela and Will did a great presentation discussing kind of the learning curve and hurdles they overcame to automate this, not with Snowflake, but with an API connection. And so they presented this at WIC Canada, our annual user conference in Calgary. So if you want a recording of this, just reach out to me, Graham, or Matthias, or anyone at Whitson, and we'll get you the recording explaining this. But it talks about how they leveraged the API connection route, and then they automated it with these SDKs. And again, they did a great job talking about the process of getting this all set up and how they're leveraging some of these results as well for engineering. So you're probably wondering, how do I do this, right? Do I have what it takes? So, based on our experience, there's really 3 main ingredients for this to work and make sure that this can happen at your company. And number 1, you need to have support from management, okay? Because there's going to be some upfront time that's going to need to be invested and put effort into this setup, okay? Secondly, there's going to need to be some people at your company who have some particular skill sets around scripts or Python to go the API or Snowflake route. Okay, so people like Clark or Angela and Will have those skill sets, just as an example. And then if you maybe don't have the right skill set within your company for this, again, Conduit is a great option to leverage their skills, and they can do it for you. And finally, the third kind of ingredient is to remind yourself, why are we doing this? At the end of the day, what is it even going to mean for us? And this is important to keep our vision on what are the benefits that we can get from this. So in the case of automating bottom-hole pressures, right, there's all these things that require that. And, just imagine the efficiencies or even updating any of your RTA work if the bottom-hole pressures were automated and actually making RTA on every well a realistic thing. It requires something like this. Okay, so just keeping the prize in front of you is also important when you ask for justification to management, which is ingredient number 1. Okay. So back at the start, I explained how my Norwegian employer Whitson uses this terrible email system called Mostric, and what a waste of time it is for me to manually get my new emails in, see everybody's email, filter it, and it's just brutal, right? What a time waste. And hopefully that may have triggered you because it reminded you of some sort of manual process that you are suffering from as well right now regarding engineering or something at your company. So the whole point of today is I just wanted to give you hope, right? That there are solutions if the right ingredients are present to automate these sorts of things. All right. So if you have any experience automating something like this, comment about it below. Or if you have hit a wall or a roadblock, you know what the goal is, you know what the prize is. Talk about what that was, and reach out to Matthias or I, and we'd love to get you there. Thanks a lot for listening.